Okay, this video is going to be on how to draw circles, parabolas, ellipses, and hyperbolas. And I'm probably going to start with circles and go to ellipses and then do parabolas and hyperbolas. So, assuming you got graph paper, the traditional way is, let me give you a circle to graph. So the circle that I'm going to give you to graph is going to be x minus 3 squared plus y plus 2 squared equals 9. Now let's make it equal to 16. Okay, so now that means that this circle has a center at 3, negative 2. Remember that you got to do the reverse, because it's basically, well, I'm not going to get into that right now, but this is a center of 3, negative 2, and it has a radius of 4. So that's assuming you know some stuff about circles already. Okay, so now sort of the traditional way of doing this is you do out your t-table, or you sort of go out like this, and you go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Put the center at 3, negative 2. And then you go, oh yeah, and so it's got a radius of 4, so 1, 2, 3, 4, so that's going to be a point. And then 1, 2, 3, 4, that's going to be a point. And then, oops, gotta add out here 1, 2, 3, 4. This is a point. 1, 2, 3, 4. This is a point. And so those are the points that are on my circle. And now I've got to sort of connect them up as a nice circle. And so I go as best as I can, and I end up with a potato. Now I'm not going to give you much better than a potato in this video, but there's a better way to do this. And also the other thing that I don't like about this is this point should be the center of our graph. Not this point. I don't care that the origin should be the center of the graph. I want this point here to be the center of the graph. So let's do circles a different way. Okay, the way that we're going to do circles a different way is our goal is to draw a circle. So we're going to start by drawing a circle. And so there's my circle, and then I'm going to say that the center of my point is going to be 3, negative 2. And so, and my radius is going to be 4. So if my radius is 4, this is going to be the point 3, 2. And this is going to be the point negative 1, negative 2. And so now I know that if my radius is 4 and this is negative 2 and that's positive 2, that my x-axis is going to go right there. So that's going to be my x-axis. And then I know it's going to be halfway between, so this is halfway between there and there. And then I know that it's going to be about 3/4 of the way this way, so if I go 1, 2, 3, 4, somewhere right in there, that's going to be my other axis. So this is my x-axis, this is my y-axis, and this is my x-axis. Okay, now the point that I want to make in this is that we are starting with the circle, and then we are adding in the coordinates the coordinate plane afterwards. And it's a lot easier to add straight lines onto a curve than it is to add curves onto a straight line. Okay, so I lied a little bit ago. I'm actually going to draw parabolas before I draw ellipses. Okay, so the thing is that all parabolas have the same shape. Okay, so I think you can buy that all circles have the same shape. People have a harder time believing that all parabolas have the same shape, but they do. People will say, no, but there's parabolas that look like that, and there's parabolas that look like that. But they're actually all the same shape. All this is if I took this part of this parabola and I blew it up, so these two boxes are the same. So it's really it's really zoom. So if you zoom out, you get a parabola that looks like this. If you zoom in, you get a parabola that looks like this. The key thing about a parabola is, here's the key thing about parabolas. It's in the definition. The set of all points. The set of all points equidistant from a point and a line. So we have a point, which we're going to call the focus, and we're going to have a line, which we're going to call the directrix, and halfway between those, equidistant between them, we're going to have a point called the vertex. And now it's going to open up in a very predictable way. And the way that it's going to open up is that basically, if I think about it, this distance here is twice. So I want to make square boxes. I want to make a square box here. I want to rotate up like that. That's going to be a point on the parabola. And then this is going to be a point on the parabola. Well, somewhere like right there is going to be a point on the parabola. Because here, this distance here is equal to this distance there. And this distance here is equal to that distance there. So I have these sort of like imaginary square boxes that I'm not going to draw in because they're going to complicate things. But a parabola, now, and I'm sort of violating my law. Now I've got these dots, so the dots are going to confuse me. But basically, a parabola just kind of goes like that. So it just kind of goes out like this and out like that. So what I'm going to do is, when I want to graph parabolas, I'm going to just start with my graph, and I'm going to just start with my parabola. So I'm going to make a sort of a parabola that comes like that, and I'm going to make another parabola that comes something like that. Okay, so now let's focus on this one. So we're going to say that this one is going to be let's say we're going to have y equals x minus 2 squared. Okay. Well, that means that that's going to have a vertex at -2, 0. And so right off the bat I can plug in my horizontal and vertical axes. So my y is 0, so that's the point -2, 0. So I'm going to throw this in like this. So there's my x-axis. Now the next thing is that we're going to say that this is -2. Well, what do I get if I plug in 0, 0 into this? If I plug 0, 0 into this, I'm going to get 0, so I'm going to get 4, 0, 4. So I'm going to get 0, 4. So I'm looking for a point kind of 1, 2, somewhere out here. 0, 4, and so that's going to be my y-axis. So here's my parabola, y equals x minus 2 squared. Okay, so now let's come over here and look at this one, and I'm going to sort of make this one a little bit more complicated. I'm going to sort of build up in difficulty, and I'm throwing a lot of things at you. This one is going to be minus y squared minus 2y plus 4x minus 1 equals 0. Okay. Well, I'm sorry, I want to make that a minus 4x. Okay, so I'm throwing a lot of things in here. This is nowhere near standard form. So first off, what we have to do is I can see I want to group these. I want to go minus y squared minus 2y minus 1, and then I want to do minus 4x equals 0. Now I want to move that over, and I want to do some grouping. I'm going to take a minus out, and I'm going to get y squared plus 2y plus 1 equals 4x. And now I'm going to want to do minus y plus 1 squared equals 4x. Okay. So now I've got it, and well, I'm going to just change it around. 4x equals minus y plus 1 squared. So now I've given you a difficult one. This, because the y is squared, it's going to open horizontally. So x squared means vertical, y squared means horizontal, and because it's negative y squared, it's going to open to the left. So well, here I've drawn my parabola, but we can do this. So there I've got it opening to the left. And so now here, let's go back here. My vertex is going to be 0, negative 1. So this point here is going to be 0, negative 1. And I ask myself, what happens if I plug in x equals 0 into here? Well, I get negative 1. So here's my y-axis right here. This is my y-axis. And if I plug in 0 for y, 0 for y, I'm going to get 1 squared is 1, negative 1, so 4x equals negative 1, so x equals negative 1/4, so it's going to be somewhere down here. This is going to be the point 0, negative 1/4. Okay, so now there's my parabola that I've graphed very quickly. I started with the shape because all the shapes are the same. Then I figured out where my axes are and I put my intercepts in, and there I've got a passable sketch for our parabola. The ellipses are up next. Okay, so here is an equation for ellipse, which is nowhere near standard form. So we're going to do some completing the square, and we're going to get this into standard form. So we're upping the difficulty as we go along in this video, probably faster than you want it to go up. Okay, so first off, I've got to group all the x terms, and I'm going to be doing completing the square. So right off the bat, I'm going to give myself some room that I'm going to fill in a little bit later. 16x squared minus 32x plus blank plus 9y squared plus 36y plus blank equals 92 plus blank plus blank. So I'm going to add stuff into these two blanks, and whatever I add to the left side, I need to add to the right side to make the equation still hold. Now I'm going to do a little grouping here. This has 16 in it. This also has a 16 in it. So I'm going to pull a 16 out. I'm going to get 16 parentheses x squared minus 2x plus blank plus, this is a 9, that also has a 9, 9 y squared plus 4y plus blank equals 92 plus blank plus blank. Now I take half of this and square it to complete the square. So negative 2 divided by 2 is negative 1, squared is 1. So I put a 1 in that blank, which is multiplied by that 16. So I'm going to have to put a 16 in this blank. Half of 4 is 2. 2 squared is 4. So I'm going to put a 4 there. Times 9 is 36. So I'm going to put a 36 over here. Now this is a completed square, and this is a completed square. So I'm going to do 16, and that's going to be x minus 1 squared plus, that's going to be 9 y plus 2 squared equals 92 plus 16 gives me 108 plus 36 gives me 138, 144. And now I'm going to divide everything by 144. And so now I'm going to get 144 divided by 16 is going to be 9. (144) divided by 9 is going to be 16. And that's going to be equal to 1. Okay, so now looking at this, this is in standard form for an ellipse. So my center is going to be at 1, negative 2. And my A, my semi-major axis, is going to be square root of 16 is equal to 4. My semi-minor axis is going to be the square root of 9, which is going to be 3. So it's going to be, this is going to be my vertical, this is going to be my horizontal. So my ellipse is going to be a little bit taller than it is wide. Okay, now I'm not really good at drawing ellipses that are a little bit taller than they are wide. I'm a little bit better at drawing them that are a little bit wider than they are tall. So I'm going to turn my page, and I'm just going to draw an ellipse that is a little bit taller than it is wide. Okay, there. A little bit taller than it is wide. Not as good as a computer can do, but it's a lot better than connecting the dots. Now, that's going to have a center of 1, -2, and it's got a semi-major axis of 4. So this distance is going to be 4, that distance is going to be 4. This distance is going to be 3, the semi-minor axis is 3, that's 3. So now I can add in some points along the side here. So 1 minus 3, so 1 minus 3 is going to be -2. -2 is that point right there. -2 plus 4, so that's going to be 1, 2. This is going to be 4, -2. And this is going to be 1, -6. So now I can add in my axes. -2 to 2, so I just go right halfway between those. Boom, that's roughly halfway. So that's my x-axis. And then here I've got here I've got 1 and here I've got -2. So I'm going to be about 1/3 of the way over. And so there's my y-axis. And so there is my sketch of an ellipse. Okay, hyperbola is next. Okay, so we're going to do a real quick hyperbola here. So a hyperbola looks very, very similar to an ellipse. So here's my ellipse equation here. And the difference between an ellipse equation and a hyperbola equation is in an ellipse that's a plus, in a hyperbola that's a minus. Okay, so I've got it in my form here. So my center is going to be -1, -2, and then I'm going to go horizontally. I'm going to go square root of 4 plus or minus 2, and vertically I'm going to go square root of 1 plus or minus 1. Okay, now the key thing is that we have to sort of violate what I've been talking about for hyperbolas. We have to sort of draw the rectangular box first and then go from there. Okay, so what we're going to do is first off we're going to just make our center right there, and so our center is going to be -1, -2. Now my box is going to go horizontally plus or minus 2. So let's go out here. That's 1, that's 2, that's 1, that's 2. And it's going to go vertically plus or minus 1. So if that's boom, boom, like that, and like that. So there I'm going to get a box. So I've started with the center of my hyperbola, and then I've made a box. And if I want to, I can figure out this point here is going to be, this point here is going to be 1 comma negative 2. This point here is going to be negative 3 comma negative 2. This point here is going to be negative 1 comma negative 1, and this point here is going to be negative 1 comma negative 3. Okay, now that box is going to define my asymptotes. So my asymptotes are going to run along the corners of the box. And I'm freehanding things, so my center sort of got a little bit messed up. So now the question is, does it open this way or does it open this way? Well, let's try this point here. Let's try negative 1 comma negative 1. If I plug in negative 1 in here, negative 1 plus 1 is 0, and then negative 1 plus 2 is 1, so that's 1 squared divided by 1 gives me negative 1, so negative 1 does not equal 1. This point is not on the hyperbola. Let's try this point, 1 comma negative 2. I plug in 1 plus 1 is 2, squared is 4, divided by 4 is 1. Plug in negative 2, and I get 0. So by plugging and checking, there's other ways I can figure it out, but by plugging and checking, I know that this is a vertex, and this is a vertex. So it's going to open this way and that way. So now to draw my hyperbola, I'm going to start here, and I'm going to come in, and I'm going to head out towards my asymptote. I did it a little bit there, but don't roll away from the asymptote. Come right up onto the asymptote, and then follow the asymptote. Don't roll away from the asymptote. You want to get closer and closer to the asymptote. Don't just swing right onto it and then follow it. It's going to get there pretty quickly, and then it's basically going to follow the asymptote. Okay, so there's my hyperbola, and then the last thing I need is I need my axes. Well, if this is a distance of 1 and I gotta go another distance of 1, so there is my x-axis right in there. And if this is negative 1 and this is positive 1, then my y-axis is going to go right in here. Okay, so that is a very rapid look at a lot of different graphing of conic sections.